Good morning, friends. Today I will discuss with you electrochemical cells. See, whenever a reaction takes place, that is oxidation and reduction, they are simultaneously takes place. That is, if one loses the electron, other will get the electrons. That is known as the direct redox reaction. And in such type of the reactions, the chemical energy generally changes to the heat. But if we take the indirect redox reaction, that is oxidation and the reduction, they are separated out by insulated copper wire. Then it was found that the chemical energy is converted into the electrical energy. So electrochemical cells, we can say that is a device in which chemical energy converted into the electrical energy. Now, if we take reaction of the copper and the zinc, if we take two beakers, in one beaker electrolyte zinc sulfate 1 molar solution, in second beaker electrolyte is copper sulfate 1 molar solution, and in the zinc sulfate zinc electrode and the copper sulfate copper electrode, and these electrodes, they are connected by the insulated copper wire having bond K and ammeter. Now here, if you see that one cell contains the zinc electrode and the zinc sulfide electrolyte, while the other contains copper electrode and the copper sulfate electrolyte. Now let's see the reaction of the zinc to the copper. Simply we say that the zinc gives the electron to the copper and the copper is deposited at the electrode. This is somehow we say that the half cell and the half cell. Now these two half cell, they are connected by a tube which is filled with inert electrolyte like KCl, potassium chloride or the potassium nitrate, which is inert in nature, that is it doesn't take part in the reaction, that is the zinc sulfate and the copper sulfate. This is known as the salt bridge. Now when K is put on, we say zinc gives the electron, moves toward the copper. So in our reaction, if we see that zinc gives electron to the copper and the copper is deposited on the electrode. Now what was the observation? It was found that zinc rod loses the weight and the zinc ions goes to the solution and the concentration of the zinc increases, while in the case of the copper sulfate the concentration of the copper sulfate decreases and the weight is gained in the case of the copper electrode, while the solution remains neutral. Now here I will explain you very important thing, that the two half cells connected with a salt bridge. We say that the continuity is maintained by the salt bridge. Now here see first half cell and second half cell. In first half cell, that is known as the oxidation half cell, where zinc gives the electron and zinc goes to the solution where concentration of the zinc increases and there is a loss in the weight of the zinc. Now second is reduction half cell where copper gains the electron and copper deposit on the electrode. So there is a gain in the weight of the electrode and concentration of the copper sulfate decreases. So that is known as the indirect redox reaction. And if we sum up this reaction, that is zinc gives electron to the copper and zinc ions are formed by the copper deposit on the cathode. Now we see this oxygen half cell and this is the reduction half cell. So we say that if zinc anode, copper is cathode and it is in between a salt bridge. So zinc anode, that is anode, and zinc is immersed in 1 molar solution of the zinc sulfate. On the other hand, copper cathode, copper and the 1 molar solution of the copper sulfate, and it is the salt bridge. So this is how to represent this indirect redox reaction. Understand? So two half cells are there which net gives the indirect redox reaction. Now, the very important thing is that what is the role of the salt bridge? Listen, this salt bridge which contains an electrolyte which is inert in nature, that is potassium chloride. Now, listen, here concentration of the zinc sulfate increases and here concentration of the copper sulfate decreases. It means here zinc ions increased and here sulfate ion increased. Now to maintain the concentration of the electrolyte, zinc sulfate and the copper sulfate, here the inert electrolyte which gives potassium and the chloride ions, whenever here zinc ions increase, zinc ions and chloride ions, they neutralize each other. In the same way here, when sulfate ion increase, that is neutralized by the potassium. So the very important role of the salt bridge is to maintain the concentration of both the electrolytes. So salt bridge that connects the solution of the two cells and complete the circuit and keep them neutral, and the electrolyte KCl which gives potassium and the chloride ions, this maintains the concentration of the zinc sulfate and the copper sulfate. So electrochemical cell, that is a device in which chemical energy converted into electrical energy, and these are known as the indirect redox reaction. It's a very important thing how the electrochemical cell works. So I think it will be clear to you, but the most important thing is that how this indirect redox reactions is to be represented. See here, zinc anode, copper cathode, and in between two, that is salt bridge. Here zinc is dipped in 1 molar solution of the zinc sulfate, that is the oxidation, and on the other side copper cathode, that is having 1 molar copper sulfate solution, and this is the reduction cell. So two cells connect to form the indirect redox reaction, that is the electrochemical cell. So if you like my videos, please share and subscribe. Thanks very much.